Hi, I'm Max Corbell, and today I'm presenting the ROHD Hardware Component Library. ROHD-HCL is a free, open-source library of high-quality, configurable hardware components for design and verification, with excellent documentation. The guiding principles are that components should be general, easily reusable, and as configurable as it may be useful. Components are extensively tested and come with excellent documentation and examples. The first component in each category should be the simplest, and the focus should be on the breadth of types before depth. The library encourages a focus on correctness first, then optimization. Testing ensures that functionality is not compromised in the pursuit of performance. The library contains a wide variety of types of design components and associated verification components. ROHD is an open-source generator framework for both design and verification, written in the Dart programming language. ROHD includes a fast, event-based 4-value simulator with X and Z propagation, and Dart has a great unit testing framework. This combination makes it really easy to unit test components in the library. Dart with ROHD makes it easy to take advantage of modern software development techniques to accelerate hardware development. ROHD-HCL offers a set of unique advantages over most other hardware component libraries. Many other hardware component libraries include a variety of components as part of the language or framework itself. ROHD-HCL offers a clear dividing line between core functionality of ROHD and a collection of components. The ROHD framework contains a strong and complete foundation, while other packages like ROHD-HCL provide opinionated and specific implementations that leverage that foundation. Some component libraries do not come with tests, or at least not ones that are good or easy to find. The test suites for components in ROHD-HCL protect functionality, build confidence for users who can review what has been tested, and also provide examples of how the APIs can be used. Excellent documentation is crucial for every component to enable actual usage. Many libraries have incomplete documentation for components, so users looking for something might not even find an existing component meeting their needs, or may be unable to effectively use what they do find. Open source verification components are generally hard to find, partially because UVM is not compatible with most free or open source EDA tools. The ROHD ecosystem includes the ROHD Verification Framework, or ROHD-VF, which enables scalable test bench component development using ROHD. Components like BFMs, checkers, monitors, trackers, etc. are a critical piece of developing large hardware designs, and ROHD-HCL is building up a collection of these for free use by anyone. With ROHD COSIM, you can even use these verification components in the library to verify system Verilog designs. ROHD-HCL leverages the entire ROHD ecosystem, including the verification framework and co-simulation capabilities. Standard interfaces are often re-implemented in different designs. ROHD-HCL provides configurable implementations of common standard interfaces, like APB. Configuration information can be queried by designs on either side of the interface, as well as by verification components attached. Standard interfaces also enable the ability to automate handshaking, even between different protocols, making designs more easily composable. Components in the library are implemented using ROHD, so it's very easy to instantiate these components within your ROHD design or test bench as normal Dart code. The configurator class makes it easy to configure components with a consistent API. For example, we use it to generate schematics, run basic tests, save configuration information, generate system Verilog, and within the web app. The web app is an online tool for configuring, generating, and visualizing system Verilog for components within the library. The web app is live, and you can find a link to it on the ROHD-HCL GitHub repository. This code is for a floating point adder for any mantissa and exponent widths. The code has been modified and trimmed to fit on the slide, so it's not complete here. The floating point type is an extension of the logic structure class, which lets us add helper functions but still treat it like a packed single bus. The ppgen argument to the constructor is a function which generates a parallel prefix tree. The function is executed upon generation of the consumers of this argument. ROHD-HCL comes with a number of generators, including for architectures like Kogi Stone and Brent Kung, but a user could provide their own as well. This generator is used to generate an encoder, but also to create another generator for an adder, where an adder is a base class, which parallel prefix adder extends. This component leverages other components from the library, like the ones complement adder and the parallel prefix priority encoder, which are independently usable as well outside of the floating point adder. An extensive testing suite and complete documentation are created for this implementation. Users of this adder can read the documentation and example, read the tests for reference, and to build confidence, and then just pass 2 floating point arguments in and get an output. The ecosystem needs more contributors. Together, we can build a substantial library of components for design and verification, enabling hardware developers to focus on adding new value rather than re-implementing the same thing over and over, and making the same mistakes and bugs repeatedly. ROHD-HCL includes a lot of documentation. The Dart ecosystem is really good, making it easy to get started quickly. The repository includes a dev container, so you can easily develop inside a container if you prefer. There's also GitHub code spaces, which makes it so you can develop in the browser without installing anything. Developing components with Visual Studio Code in a container in a browser with great IDE integration and a built-in simulator is fun and easy. You can also make your own package or even your own library, whether focusing on a niche or even competing with ROHD-HCL. The whole open source hardware development ecosystem benefits with more reusable components. I hope you'll try using ROHD-HCL today and in your next hardware project. Thank you.